Ah, there it is. Okay. Alright. So I need everybody over on page 39. On page 39. Okay, we've got a nice neat pile of quiz corrections in the middle of the table. You and your partner, you're one partner, you do not get to work with anybody else. You have the next 2 minutes to do this first question with your graphing calculator. Everybody good? Page 39, question number 1, 2 minutes, go. No. For the next 2 minutes, you get to use your calculator on this.
Oh, not our partner?
And your partner.
Apparently,
I mean, so
triple will be right back.
your song.
Okay, we're all working and we're not moving. I know it's a Monday and your ability to get up and move is going to confuse you. We're not going to do it. Right?
No, my weakness. That's kind of a stretch. I like my wham and I don't like it.
Nice splitting up, Drew.
Okay.
Yeah, that's what I have to do. Yeah, that's the one.
That's a good idea. That's what
That's the one. Yeah.
Are you sure? If this doesn't, if it isn't the right answer, I'm getting half of it.
Alrighty, friends. I've seen it on enough papers. Uh-oh. 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 Now I'm a little confused. Let R be the region in the first quadrant bounded by the x-axis and the curve y equals 2x minus x squared. Well, that is a parabola opening down, passing through the points x equals 0 and x equals 2. The volume produced when R is revolved around the x-axis. So this should be integral from 0 to 2, 2x minus x squared dx. That should be the right setup. When you plug this into the calculator, what are we getting for an answer? 3.351. That is not any of the answer choices that are up there because those are the calculator inactive answer choices. Which of those 5 is equal to 3.351? A. Okay, B seems to be a really popular answer for a whole lot of folks. Folks that are coming up with B, what's going on? Jeanette?
We didn't square the equation.
Okay, and you know you have to,
Yeah.
right? When you look at those slices, those are going to be cylinders when you spin them, so it should be pi times the integral from A to B of your function squared, and you integrate with respect to x. How many guys honestly had A as your answer? And where are all the folks that had B? Okay, there were a lot more folks that had B than that. You have to read carefully. If it's an area problem, you do it one way. If it's a volume problem, you do it another way. Henry?
How would we do it if we did it by hand?
Okay, that's where we're going to go to in just a little bit. All right, so if you got it right, you and your partner got it right, you stay together. If you and your partner got it wrong, time to move. Bye-bye.
Don't disrespect me.
Given the number of people that just got this wrong, there should be movement happening. I feel like I'm reliving that morning where I got really angry and all the demerit cards came out because people weren't doing what they needed to do. If you got it wrong, you're moving. That's how it works. Okay, page 40, question number 5, please. No calculator. Hi.
I got like a 1.006 something converted to a fraction.
No, you didn't do that correctly. 16 over 15.
Yeah, but I didn't multiply by pi. I multiplied by pi after I.
Right, okay, there's a bunch of things going on. That's the volume setup that you do. It's a hollow object. It's not a hollow object. It's solid.
This is a 50-50, 25.
That's the intersection.
Okay.
What is the value of the sun?
No, because we had to do
It's either C or D. I know it's C. I know it's C or D though. C, D, or E. Because you have to use one. No, it's E. It's E. It's E.
And those are things.
The white. So it always has to be 2 minus the equation. Then you have to find root because you have to find the x. So you square that and square that. It's equal to y squared.
I know this one looks like.
No, it's not.
It's like the big radius minus the little radius. Yeah, I remember that.
Yes. I don't know how to add it. No, I'm not gonna rush it.
I think in terms of
Right, and R represents the region enclosed by the graphs y equals x minus x squared over the end of 0 to 1. What's the volume of the solid that results when R is revolved around the line y equals 2? Alright. X squared, we're revolving around y equals 2. All right, let's put this together. Is everybody convinced that this is the right region?
Yeah.
Okay. Limits of integration? 0 and 1. We're spinning around the line, y equals 2. And the question that everyone's going to ask themselves right now,
Is it solid or
solid,
hollow?
hollow.
is it solid or is it hollow? And the answer is
Hollow.
hollow. Hollow, hollow, hollow. Diego, are you okay that this is a hollow object? Okay, Diego, what's hollow?
It's not touching the y equals x squared. Y equals 2.
Right, you're only going to get a solid object if your region touches that axis of rotation the whole time. So as soon as you know it's hollow, we're going to do pi big radius squared minus the small radius squared. This is when you square them separately and no other time.
Oh wait.
Hold on. Your radius always starts in your axis of rotation and then you go until the outer one, that's big R. Here to the inside one, that's little r. Big R, Henry, how long is big R?
X squared. I mean, it'll be y. I mean, square root of y.
Whoa. All three completely different things you said are wrong, unfortunately. Big R, you're starting on the line y equals 2, you're going down to the parabola.
Oh, it's
It's 2 minus x squared. Right, top minus bottom. Little r, you start on the axis of rotation, you go all the way down to the line, 2 minus x. So then your setup is 2 minus x squared squared minus 2 minus x, the whole thing squared. You're going to integrate from 0 to 2. Which one is that?
B.
Oh my god, even with it on the board, people aren't sure. This is A. How many guys honestly had A? Okay, we're doing a little bit better. You and your partner got it right. Stay together. You got it wrong. Move. You need a new partner.
How come your limits of integration from 0 to 2?
Not 0 to 2, not 0 to 2. 0 to 1, my bad. 0 to 1, thank you.
so it is bigger than
My friend.
I'm going to tell you that in a second.
This is over here. Walk forward.
All right. Page 65, please. Question number 78. Page 65, question number 78. 2 minutes. Adrian, the graph is like really, really flat, and then it starts to increase.
Yeah, I'm fixing it now.
Always because it's a constant.
Right, e to the third power is constant, so that's going to be a horizontal line. Most of you guys seem to have identified the correct region. Spinning around the line y equals -1. Hollow or solid?
Hollow.
Absolutely hollow. Absolutely hollow, so your volume is going to be pi. You're going to do an integral. Something squared minus something squared dx. I cannot encourage you enough, just as soon as you recognize hollow, write that form down. And then your radius, you start on the axis of rotation and you go all the way to the outside curve. Big R. Start on the axis of rotation, go to the inside curve. Little r. Big R is e cubed minus -1. Little r is e to the x minus -1. Or e cubed plus 1, and that's e to the x plus 1. So you get e cubed plus 1 squared, e to the x plus 1, the whole thing squared.
E.
Whoa, what?
Yeah, you're good.
Oh, limits of integration?
Oh, 0 to 2.
0 to 3. X equals 3 is where they intersect. And so we're saying that that is E. How many guys honestly have this as your answer? Nice. Nice, 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 nice. Okay. One last multiple choice question, then we're going to go to free response, and you're going to start to doubt yourself. I just want you to know the 2 free response questions we're going to look at today are going to shake your confidence a little bit. Don't let it shake your confidence. What confidence? All right. Okay, very first question. Page 65, question number 12. Put that calculator away.
Just page it.
Yes, ma'am.
What's the difference like with the setup if it's on like with the setup with the same thing?
Wait, ask you that one more time.
Like what's the difference in the setup like to find the volume for like if it's on the
So if you have a solid object, then you have the same radius. So you're not doing big R squared minus little r squared, you're just going to say big radius squared. Because if it's solid, Sheila, you're going to have something that maybe looks like that. Okay? And so because it's solid, that's your radius.
Oh, okay.
It's just when you start getting hollow objects, then you need to consider like a big radius and a small radius to account for the scooping out part. Make sure you read the question carefully. It's completely calculator inaccurate.
Because the more you go right, the bigger the fraction is. So like, but you're not gonna touch it.
I'm pretty sure it does look like that. It's not. So then what is it?
So you start with X equals 1 over X.
I'm sorry. I should learn to trust this. X equals C.
C is just the area between
There's no lighting.
Most folks seem to have the correct region. Now I want to get the area, not the volume. Don't talk to me about volume. I'm not interested in volume. How do we find area? Right, we're just bounded by the x-axis.
Yeah.
So we're going to do an integral. What are we integrating?
1 over x.
1 over x is what we're integrating. We're integrating with respect to x. Limits of integration?
0 to 1.
Not 0 to 1.
1C.
You're integrating from 1 to c. So the integral of 1 over x with respect to x from 1 to c, the integral of 1 over x, everybody needs to know. You have to remember your integration formulas here. Integral of 1 over x. Oh my gosh, that sounded like 2 people out of 27. Nope, not natural log of x. Natural log of the absolute value of x. You have to have the absolute value bars in there. Natural log of the absolute value of x from 1 to c. And so we're going to have natural log of c minus the natural log of 1, and I just realized we made a mistake. And it's such a bummer. It's such a bummer, and it's on video, because if you finish it off, you're going to say natural log of c minus natural log of 1 is 0, and there's a problem. There's a problem. And it's my fault. I was going too fast here.
You switch the C was supposed to go first. I mean, like, you know.
What do we know about C?
The C is less than, smaller than 1.
C is smaller than 1. So if this vertical line over here represents x equals 1, where's C? Somewhere between 0 and 1, so that's x equals C. Now how does that change things? That means my limits of integration are different. We're going to go from C to 1. You're going to go from C to 1. And when you do the plug-in, you're going to get natural log of 1 minus the natural log of C. And that's not there. Daisy, do you see it?
Yeah, so since they're both natural logs, you're subtracting, that means this divided.
Because these are both natural logs and we're doing a subtraction, this is the same thing as the natural log of 1 divided by c. It's one of those log properties from Algebra 2 that comes up every now and again. Okay, so my bad there, but it's been fixed. All right, so here we go. If you go all the way to the bottom, you're definitely going to want some extra paper. I did not give you enough space at the bottom, I know that.
You guys need to.
If you were taking the Calculus AB exam in a foreign country in 2016, Chris, what's up? Give me a second. If you were taking it outside of the United States in spring of 2016, this is the area volume question that you saw. And I think there are a lot of parts in here that you're going to feel good about. There's a couple of parts that you're not going to feel good about. I want to see what you can do with this one, with whatever partner you're working with. The question is calculator inactive, so don't touch it. Don't touch the calculator. You've got 5 minutes. Go as far as you can. If you have questions, check with your partner on this. Do all the work on a separate sheet of paper, please. So you are coming back.
And then for the vertical line,
So you're missing.
Their bedtime.
where
You're you're missing benchmark.
So would this be spiral?
That's why the relationship is so strong.
So right now for this line is pi over 3.
Why is it pi over 3? But isn't pi over 3 greater than pi over 2? No, pi over 2 is greater than pi over 3. Because pi... Okay, so then the area will be in the middle. Pi over 3 to pi over 2. If it's in the middle, then pi over 2
Asking you questions.
That's what I...
and then it's
So if what's your what is these?
Wait, when you put sign next to the other side, isn't that arc?
negative
Arc sign of.
If you try to get rid of sign.
Yeah, I
No,
need
you know
more
how
space.
to find the dictionary? You find the
By the end.
y
Yeah, but you're getting the
you do
green
3
one.
sin of x is 3.
Pi over 3 1/3.
No, it's 3x minus. No, 3 times 1/3. No. Because in order to do 1/3, you're supposed to have it inside the part. So it's 3 times.
No, we're not.
It's like what? Negative 4.
No,
It's too complex for computing minds too.
because when it's cold, it's never
You have to
2 more minutes on part A.
No, sine to cos. And then sine to negative. Yeah.
Yes, that could work. I would hope you would know what the arc sine of 1 is. Arc sine of 1 asks the question, the sine of what angle is equal to 1?
You plug in the pi over 2.
0, 90.
Cos of pi over 2.
It sounds like degrees, but I'm confused with the
Oh,
calculus.
0.
Where's the sine equal to 1?
So then it's 3.
Oh!
Oh.
It's pi over 3.
Yeah, pi over 2.
He's the freak out. It's okay.
It's 1/2.
Oh, so arc sine, well, arc of whatever is usually the negative.
Thank you.
So the question is,
Yeah.
0 times
I
When is the sine? When is the y value?
No, it's just So what do you
Alright, friends, let's pull this one together. Side conversations are done. Okay, A, let S be the shaded region in the first quadrant bounded by the horizontal line y equals 3, bounded below by the graph y equals 3 sine of x, and the vertical line x equals k. Alright, where k is between 0 and pi over 2 is shown in the figure to the right. Find the area of S when k equals pi over 3. So right now, at this moment in time, k is equal to pi over 3, and I need area. Now, most folks got off to a good start and said, okay, how am I going to find the area? I need the area of this piece here. Think about a slice. How long is that slice?
is 3 minus
Negative
I mean, my name.
3 minus 3 sine of x, integrate with respect to x. Congratulations, just earned the first point. Okay, first point earned. Check. Limits of integration. Where do we start? Where do we end?
0 to pi over 2.
I'm not.
Pi over
3 to pi over 2.
Pi over 2.
Pi over 3 to pi over 2. Now, where I saw a lot of folks getting themselves tripped up is in the determining of when this is true. When is 3 equal to 3 sine of x? Well, that's the same as saying when's the sine of x equal to 1. On the unit circle, got it, always goes back to the unit circle. When you talk about sine and cosine for any angle, the cosine is the horizontal and the sine is the vertical. When is the sine equal to 1? When's the sine when's that triangle all vertical? At pi over 2. So you're going to go from pi over 3 to pi over 2. Now they gave no points for the limits of integration, which is strange, they often do. Now you need to find the antiderivative. What has 3 as its derivative? 3x. What has negative 3 sine of x as its derivative?
Plus
Positive 3 cosine of x. And you're going to integrate from pi over 3 to pi over 2. Second point earned if you found the antiderivative. Last point is plug in. Big parentheses minus big parentheses. 3 times pi over 2 plus 3 cosine pi over 2. 3 times pi over 3 plus 3 times cosine of pi over 3. What does that simplify to? I don't care. I don't care. Nobody cares on the free response part of the test. Because somebody in the room is going to tell me that cosine of pi over 3 is something that it's not. And you're going to throw that point away. So stop at the evaluation, and there's your 3 points. Before I take any questions, how many guys honestly would have earned all 3 points? Okay, nice. For people that didn't earn 3 points, where are the problems? Where are we running into issues? Jeanette?
I think it was the time. Like we were on the right track, but then I think the time crunch was like frustrating.
Okay. Sorry about that. The whole exam, you're going to feel that time crunch. I'm not saying that to make you feel bad, but it is a pressure situation. All right, part B. I'm only going to give you about a minute or two before we talk about part B.
What area? It's not the
So we're gonna put this.
Yeah, it's derivative, but like I don't know how to put it into.
But what is it asking?
It says the area is a function of phase.
No, that's the yeah. No.
Find the rate of change of the area as.
So does that make change?
We need the area of the stress. So basically what we got, because that's a function of scale, right? And then from there, we find the rate of change.
Area.
You still find it, you still find the area.
So couldn't we just use this, the 3 plus the 3x, and then, because instead of having k equals to 3,
The rate of change is talking about it's saying in terms of phase. Phase, so you have to write it.
okay, so like you.
All right, friends, we're going to pull this one together. Okay, part B. Part B is mean, and Destiny, it's definitely not 90 over 3 because this is a radians only place. All right, B, the area of S, hold on. The area of S is a function of K. Meaning when you talk about area, you're going to get something in terms of K. You're not going to get a number answer. They're saying K is K. It could be anything between 0 and pi over 2. That's what K is. Okay? Find the rate of change of the area with respect to K means, and I know a lot of you already know what this means because I talked to like 4 or 5 different people. Rate of change means derivative. But here's where we've got to be careful. I want rate of change of the area of S with respect to K. What derivative do I want? Derivative of the area with respect to
Okay.
K. When K equals pi over 4.
6.
It's pi over 6. My bad. It's really blurry. All right, well, how do I find area? Area is an integral. Where am I integrating from? Where do I start integrating?
K.
At K. All the way to pi over 2. And then it's 3 minus 3 sine of x. It's a lot like what we already did in part A. Yeah, Paul? The issue is this. They want you to find the derivative at a particular value. You have to find the derivative first. Then you plug in a number. If you plug in a number first and then you take the derivative, you're going to get 0. It has to be derivative first. Well, here's your area expression. Now I saw some folks, not so much right now, but last year when we did this, a lot of folks said, oh, all right, what am I going to do? I'm going to find an antiderivative. I'm going to plug in the pi over 2, I'm going to plug in the k, and then I'm going to take a derivative? Well, what we're asking for is dA, dk. I want you to find the derivative of this guy here. I want the derivative of the integral of this function from k to pi over 2. It's been a while, but it hasn't been that long. The derivative of the integral of a function, that's a really special combination that we've seen before. Derivative of the integral of a function. There's something nice that happens.
It cancels each other out because it's 0?
There is some cancellation. No, it's not equal to 0. Karina had some thoughts. Abel had some thoughts. Paul had some thoughts. Paul, I haven't heard much from you today. What are your thoughts here? The derivative of the integral of a function from k to pi over 2 is not just what you get by plugging in k. The issue is this. What you need right now is the second fundamental theorem of calculus.
There you go. That one.
The second fundamental theorem of calculus says when you take the derivative of the integral of a function from where to where. You have to get this part right. Derivative of the integral of a function, they do cancel, but only if you're integrating from a constant to a variable. So in that case, it's f of x. That's not what's happening here. You get the derivative of the integral of a function from k to pi over 2. Now what are we going to do?
Can't you flip them and flip the function?
Is it okay to flip the limits of integration?
Yes.
We've done that before, but if you flip your limits of integration, now you introduce a negative that was not there before. And so the derivative of the integral of the function from pi over 2 to k, all of this does cancel out. And what you get is the negative of 3 minus 3 sine x That's your derivative. That's good. The last thing though, you need to know the derivative at k equals pi over 6. We know the derivative, all you need to do is plug in pi over 6. So it's the negative of 3 minus 3 sine pi over 6. That one's mean. I know it's mean. Yeah, Paul?
When they took this hump, what was the average point?
It was low. I don't remember exactly what it was off the top of my head, but it was low. You guys are prepared for like most of the comfortable questions. A question like this, I wanted to make sure we talk about. Jackie.
What was the going to
Good question. I think the first point came in by even knowing to take the derivative. Indicating that you were going to take the derivative somewhere got you a point. Finding the derivative got you a point. Evaluating the derivative got you the third point. Okay, we got 5 minutes left, which is just enough time. You get 3 minutes for part C. Part C is a setup only question.
Wouldn't it be all of them? Y equals 5, yeah. Because it's not plus 5.
Yes. So it'd be 3 minus 5 squared minus.
You need to find big R if
Find x.
And then big R be 3 minus 2? I mean, 3 minus 5 and then
Minus.
nothing.
Yes.
3 sine of x. I mean 5. 3 sine of x minus 5. Hey!
I've been waiting. I've waited 30 seconds.
so it's 5 minus 3 and then 5 minus 7.
No, it's the
2
3
minutes
minus
left.
5. It's 3 minus 5 and then 3
3 minus 5.
because you're going to
I wouldn't listen to him. Remember how many wrong answers?
5 was 3. 5 was 1.
Make it wrong answer. Make it wrong answer. Get it out now.
That's equals.
Okay.
Don't listen to my words.
Wait, do I have to
I'm not going to them, my brain comprehends.
Yes.
503 squared minus 5 minus
Oh, but you're revolving around it.
pi
You don't use the
pi over 3
area.
to pi over 2. That's fine. No, so pi that's fine. 4. Yeah. I don't know.
It's still 2 minus 1.
Yeah, that's what I was thinking. So 5 minus 3 and then 5 minus.
Well, it's still solid.
It's squared separately.
So it's,
Separately. That's why I keep saying big R squared minus little r squared.
would it be minus 5 minus 3?
It should be top minus big R minus little r.
I knew that. See, I told you.
All right, friends.
It's called testing.
Okay, we're revolving around the line y equals 5. Hollow or solid?
Hollow.
Hollow. That was nice and strong. Your volume is hollow.
You're gonna play this.
Big R squared minus little r squared dx. There's your setup. Limits of integration.
Pi over 4.
Pi over 4.
Pi over 2.
Pi over 2. Good. So all the people that have the pi that you're multiplying by, integrating from pi over 4 to pi over 2, congratulations, you get the first point.
Yeah.
Now we talk about big R and little r. Here's the region. I'm spinning around here. When you do big R, you always start on the axis and you drop down. Or you go up depending on your direction here. How long is big R? 5 minus
Minus 3.
5 minus 3 sine of x and the whole thing gets squared. How big is the small radius? 5 minus 3 or 2. If you have, or 2 squared, which is 4. That's worth 2 points. That's all the points. How many guys get all 3 points on part C?
Yeah.
Good job.
Okay, much better. Here's the thing though.
Oh, we're wrong.
Quiz tomorrow, test on Friday, AP exam next Thursday. Stay with me. Part A, everybody was feeling pretty good. Part B, nobody was moving in the right direction. And my fear is that most of you would hit Part B and you would stop. Like, I'm done. The lesson to be learned here? Keep going because just about everybody picked up all 3 points here. Tomorrow, hold on. Tomorrow's quiz is going to cover cross sections, all those slices. Make sure you know your constants. Make sure you understand which direction you're slicing. Make sure you bring in your calculator. See you later.